let's start this. Remember, like terms have the same variables raised to the same power. Okay, so let's start with this because it's up front. So I'm looking for something that has just m. Well, this is negative 40m, and there is an m here, and that plus sign comes with those. So those two are together. If you want to write them next to each other, be my guest. If you don't want to, don't. The next like term is negative 24m squared, and that's going to subtract with negative 33m squared, and then minus m cubed. So that guy at the end will just hang out, do nothing. So let's actually write them in order here. So the first thing I would do is this guy, because this has the highest power. So that's just negative m cubed. These two I'll combine next. Negative 24. We combine the coefficients, right? So it's going to be negative 24, negative 33, negative 57 m squared. And lastly, negative 40m plus, and if you want to put a 1, you can put a 1. So negative 40 plus 1 is negative 39m. That's your final answer. Now, if you wrote this in a different order, that's fine. I won't lose any points. This one, it's also combined like terms, but you have to do the distributive property first. Okay, so 4/5 times 2/7, well, it's just 8 over 35k. Next one is positive and negative. It's going to be negative. And 4/5 times 35, let's see, it's 28m. Positive times a negative is a negative, and 4/5 of 10 is just going to be 8. And then minus 5 over 7k. Do we have like terms? Yeah, this guy over here and this guy over here like terms. So let's put them side by side. 8 over 35k minus 5 over 7k minus 28m and then minus 8. So these two guys here do absolutely nothing. The only thing that you have to worry about is these two terms, and those will be combined. But we can't combine them because they don't have common denominators. So go back to your second grade where you learn to add fractions. The LCM is going to be 35, so this is going to stay as it is. This is going to change to 35, right? We're going to find an equivalent fraction. We're going to change 5/7 to an equivalent fraction, but with a denominator 35. So how did the 5 become 35? It was times 5, so I'm going to multiply the top times 5, and we get 25. Minus 28m minus 8. Positive 8 minus 25 is negative 17 over 35. Oops, 35k minus 28m minus 8. And that's your final answer for that. Okay, this might be a long video. Okay, distributive property. These have to be multiplied. These have to be multiplied. And the only thing that doesn't multiply is the 3m, right? So, careful with your, when you multiply these two, because you got to account for the variables that are also being multiplied. So negative 3 times negative 6 is positive 18. A to the first power times a to the third power is a fourth, b squared. Negative times a negative is a positive. 3 times 12 is 36. A multiplies with, there's no other a, so it's still part. B to the second power times b to the fourth is b to the 6. Plus 3a, and then we're going to multiply this. So it's a negative times a positive, which is going to give me a negative. There's a 1 here, right? So 1 times 4 is just 4. A squared times a squared is a to the 4th power, and b times b is b squared. Last one is negative times a positive, which is a negative, and 1 times 9 is 9, a squared b. Like terms. Yeah, there is. This guy here is an a fourth b second, and this one is a fourth b second. It's the only two like terms. So those are the only two that you're going to combine. So 18 minus 4 is 14, a to the 4th b squared. Then I'm going to write this guy here. Plus 36 a b to the 6th power plus 3a minus 9a squared b. Again, now distributive property. If you want to think that there's an invisible 1 there, you can do that, or understand that there's a minus sign in front of parentheses, so everything inside is going to come out the opposite, right? So that's going to change the sign of our terms inside the parentheses. So if you do this theory property and you think about there's an invisible 1, you get -1 times -8, which is +8, right? So negative times a negative is a positive, and 1 times 8c is just 8c. Again, negative times a negative is a positive, and 1 times c squared is just c squared. Again here, negative times a negative is a positive, and 1 times c is just c. And negative times a positive is a negative, and 1 times c squared is -6 squared minus 12c. Right? Combine like terms, yeah, this c squared and the -6 squared, actually they cancel each other out, so that becomes 0. And the rest is c. That's an 8c, that's a c, and that's a -12c. So 8c plus c minus 12c. Well, 8c and c is 9c, and 9c minus 12c is -3c. So that's the answer for that. Okay, so this one, let me just raise the sheet a little higher. All right, so this theory property happens here. So we got 2kp times 3/8 of k cubed p to the 4th power. So let's do the fraction first. So 2 times 3/8 is just 6/8. K times k cubed is k to the 4th. P times p is p to the 4th is p fifth. Minus, and then 2 times 1.2 is 2.4. K times k is k squared, and then the p. Plus 4/5 k squared p. The only two you can combine is this guy here, this term with this term. They are both k squared p. So 6/8, I'm going to simplify to 3/4 k4 p to the 5th power. That doesn't combine with anyone, but these two I'm going to combine. So that's 2.4, and this is 4/5. Now I'm going to change that 4/5 to 0.8 k squared p. So they're both decimals. They're both negative, so it's -2/4 minus 0.8. It's going to give me -3.2 k to the 2nd power p. Which one am I doing right now? Oh, this one. Okay. Distributed property, distributed property, distributed property, distributed property, and then combine if possible. 1/3 times 4/7 is going to be 4/21c. 1/3 times -18. 1/3. So it's positive times a negative, which is a negative. 1/3 times 18 is just 6. And then we're going to multiply these two. Negative times a positive is a negative. 1/2 times 1/3 is 1/6. Negative and negative is a positive. And what's half of 12, which is 6. All right. Combine like terms. Well, the 4/21. Oops, I forgot a c here. So, first of all, we have a -6 and a +6. So these two go away. It becomes 0. Now we have 4/21c and minus 1/6c. They're both, so let me write them side by side. And then we can find a common denominator, figure out equivalent fractions. So the common denominator between 21 and 6, I'm just going to make that 126, I'm sorry. So I'm just going to make that 126. I'm just going to give 126. 6 times 4 is 24. 21 times 1 is 21. Now I can subtract them. It's going to be 3 over 121, 126c, and that is, they're both, divisible by 3. Let's see, 126 divided by 3 is going to be 42. So 1/42c. Alright, so that's a lot of... Next one, factor. So we want to take the greatest common factor and variables that they share, right, out. So this is going to be something like this, right? As far as the numbers go, the coefficients 12, 20, and 24, the greatest common factor looks like a 4. And they all share a b. So now think about 4 times what would give you 12ab squared. Well, 12 divided by 4 is 3, and then if you why do I need to multiply b by to get ab? Would be okay. Next one, 4b times what equals 20b would be just 5, right? 4 times 5 is 20, and then b just tags along. 4b times what equals 24bc? Well, it can be 6c. If you multiply 4 times 6, you get 24, and then multiply b and c, you get bc. That's factored out. Same thing here. We have 3 terms inside. 1, 2, 3. Greatest common factor between 30, 18, and 60. Is 6. I think it's 6. The x's, there's an x to the 5th power, x to the 5th power, and x to the 6th power. So they each have at least x to the 5th power. Y to the 6th, y to the 4th, y to the 4th. So the highest one is y to the 4th that they all share. And z to the 7th, z to the 5th here. So we're going to write z to the 2nd power. Okay, so 6 times what is negative 30? It would be negative 5. No x's, but y to the 2nd and z to the 5th. 6 times what's 18 is 3. No x's, no y's, and z to the 3rd power. You can always double check by doing the distributive property. And you should get this, and then you should get this. And 6 times what's negative 60 would be 10. X, right? Because x to the 5th power times x would give us x to the 6th power. So we don't need y's, and we don't need z. So that's the final answer. Actually, these two I'll do it a different method. So 56. So what? I need some room. So let me take this guy. Hold on a second. Let me do that. I'm gonna take this guy so I can have more room. I'll put it over here. So this one, I'll do it that other method where we factor it out. So some of you might actually like it. So remember, we rewrote this, we expanded it out and wrote the coefficients as the product of its prime numbers, and then we expanded the exponent. So 56, a fourth, b to the 5th power. Well, think of what 56 is. 56 is 8 times 7. 7 is the prime. 8 can be broken up in 2 and 4, and 4 can be broken up in 2 and 2. So a product of its prime. So 56 can be rewritten as 2 times 2 times 2 times 7, and then we're going to write A, and 5 B's. 1, 2, 3, 4, 5. So I'm expanding the variables, right? The exponential notation into standard notation. Now, 18 is what I wrote here. Think about it, it's 3 times 6, and 6 is 2 times 3. So we're going to write 18, a to the 5th, but we're going to write 18 as, remember, columns, right? Remember? Let me draw some columns here. So each of these go in different columns. Right, so we go here, we go here. We're going to have one more. So as of now, 18 is 2 times 3 times 3. Well, the first two here, this 2, I'm going to write under existing 2 column, and there is. These 2 3s, notice that there are no 3s in the previous numbers, so I'm going to create 2 more columns here on the side at the end. And I'm going to put a 3 in a brand new column and 3 in a brand new column. Okay. And then we're going to do 32. So we're going to break 32 and rewrite it as a product of its prime factor. So 32 is 4 times 8. 8 is 2 times 2. And 8 is 2 times 2 times 2. So 32, a to the 4th power, b to the 2nd power, can be written as 2. There's 5 2's. 1, 2, 3. Notice that I don't have an existing 2 to write the next 2 under, so I'm going to extend this at the end, make 2 brand new columns. Write a 2 over here under a new column, and a 2 over here under a new column. Okay. We have 4 A's, so we're going to write this A under this column. Oh, sorry. Let me finish that. This A under this column, this A under an existing column, and the 4th A under this existing A. And then B to the 2nd power, well, there's already a column for B, so I'm going to write that here and write this here. Let me go to the previous number. We had 18 a to the 5th power. I wrote 18 as 2 times 3 times 3, but I forgot to do the a to the 5th power. So again, there are 5a, so the first a can go here, the second a can go here, the third a can go here, the fourth a can go here, but I need one more column for a, so notice that I have to create one more. So way at the end here, I'm going to write this a in the brand new column. Okay. Now, the greatest common factor is anything that exists in all three lines. So for example, this 2 here, it's here, and it's here. So that's common. These two, there's 2 in both, in 2 numbers, but not on the third one. So that's not common, that's not common, that's not common. But a's, everybody shares 1, 2, 3, 4. So all these 3 terms over here, they each have a to the 4th power. So I'll bring that 2 down, I'll bring this a down, I'll bring it down, bring this down, bring this down. Do they share any b's? Yes. Each of them, nope, sorry, take that back. They don't share any b's because this middle term here doesn't have any b's. So that's it. The only thing they share is 1, 2, and 4a. So here's the beauty about this. It's pretty easy to figure out what the other numbers are. Okay. So the number outside is going to be whatever we brought down. So in this case, we only brought a 2. So it would be 2, and then how many a's? A to the 4th power. That's what goes outside. Now, in this first spot here, the first term, is going to be everything that I didn't circle. So it would be a 2 times a 2 times a 7, and that's going to be 28. As far as the letters that were not circled, we had 1, 2, 3, 4, 5 b's, b to the 5th power. Let's just confirm. Multiply this times this. 2 times 8 is 56. Check. A to the 4th power times b to the 5th power is a4, b5. Ta-da! The middle term. Well, look at the middle number, 18. So as far as coefficients, well, nothing. And we have a 3 and a 3 and an 8. So 3 times 3 is 9. And then we bring the a down. So let's multiply. 2 times 9 is 18. Check. A to the 4th times a to the 1st power, a to the 5th. That works out. So this, the middle term, is correct. The last term over here, it's whatever was not circled, right? So it's a 2 times a 2 times a 2 times a 2. So 2, 4, 8, 16. So we're going to write 16 here. Remember, we have to multiply, right? And then 16, and as far as letters, we have 2 b's that were not circled. So b to the 2nd power. Double check. 2 times 16, 32. A to the 4th power times b to the 2nd power is a4, b2. Yeah. Not too sure how many of you like this method. Okay, but it's an option. Okay. Now, if you don't like the method, you could have just sort of figured it out, right? So, greatest common factor between 56, 18, and 32 was 2. Look at the variables. What do they each share? Well, they each share a's. What's the highest number of a's that they each share? Well, there's 4 a's here, there's 5 a's here, there's 4 a's. So everybody has at least 4 a's, so a to the 4th power. Do they share b's? No. The middle term has no b, so we can't pull that out. 56 divided by 2 is 28. And then what do I multiply a4 to get a4 b5? Well, times b5. Second one, 18 divided by 2 is 9. And what do I multiply this guy here, a4 to get a to the 5th power? Well, multiply it by a. Last one, 32 divided by 2 is 16. And what do I multiply a4 to get a4 b squared? Well, that. And you can always double check, distribute it properly, and see that you get those 3 times. Okay. Right. So the last question I'm going to do that second method again. Okay. I like it. I really like it. I like doing it. You know, it's a little bit more work maybe, but I don't know. Maybe because I learned it that way as well. All right. So remember, we have to expand this and write the coefficient in terms of as a product of its prime number. So let's start with 14x cubed y to the 4th power y. That's easy. 14 is just 2 times 7 times x times x times x times y times y times y times y. And I'll make columns, right? 28. 28 x to the fifth, y to the fifth. So 28 can be written as 4 times 7. And we can break 4 into 2 times 2 times 7. So we need a 2. There's a column already for 2. I need another 2. Well, there is no existing 2 columns, so I'm going to put that 2 over this corner, brand new column, sorry. And then this 7 over here, well, there's an existing column for 7. I put it over here. 2, 7, and 2. Good. X to the fifth power, so I'm going to write, I need 5 x's. 1, 2, 3. There are no columns for x's, so make 2 more. Another one here. Another one. So I'm going to expand that. Hopefully I don't have room. Y to the fifth power, well, there's already 4 y's, so column for y, another one, another one, another one, but I need one more. I'll put that all the way at the end. And then finally, 98. 98 x to the sixth, y to the second power. So y to the second power, those are the y's. So the y's is, I'll put one y here under existing y column, the second y over here. X to the sixth power is going to be, well, x, 1, 2, 3, 4, 5. And they're going to put that x way at the corner there. I don't know, hopefully you can see it, right? Because it needs to be under a new column. And then 98, oh, this is going to be 98, let's see, can be broken up in 2 and 49. And 49 can be broken as 2 times 7 times 7. So I need a column for 2. There is one here. I need a column for 7. And guess what? I'm going to make a column for 7 on this side, because I just don't have room on that side. Okay, so, and then over here, so just remember that there's an x by itself over there. So the GCF, hopefully I'm correct, is anything that appears in all 3 numbers. Well, these 3 2's show up. There are 3 7's, there's 3 x's, there's 3 x's, 3 x's, this and this. These, there are only 2 y's, there's only 2 y's, and these, they don't have anything in common. So what's in common is 1 2, 1 7, 1 x, another x, and 2 y's. So if I multiply that, I get that 2 times 7 is 14, and I get x cubed. So let me write it here at the bottom. Let me write it this way. Right, so we need 3 terms inside, and the number outside is going to be 2 times 7, which is 14, x to the third power, y to the second, because there's 3 x's and 2 y's. Okay, so now let's figure it out. On the first line, what didn't I circle? Well, the only thing I didn't circle was these 2 y's. So I'm going to put that over here as y squared. Confirm. If I do the distributive property, multiply these 2, do I get this? Yes, I do. Right? 14 times, there's a coefficient of 1. 14 times 1 is 14. X cubed goes in there, and then y to second power times y to second power gives me y to the fourth. Check. Middle term. What didn't I circle? I didn't circle a coefficient of 2, so that goes in here. There's only 1, 2. I didn't circle 2 x's and 3 y's. So 2 x's is x squared, and 3 y's would be y cubed. That's confirmed. 14 times 2 is 28. Check. X to the third, x to the second is x to the fifth. Check. Y to the second, y to the third is y to the fifth. Check. And the last one, what's not circled? Well, there's a 7 and 3 x's. So 7x cubed. 14 times 7, is that 98? Yes. X cubed times x cubed is x to the sixth power times y to the second power. Okay, so if you want to do it that way, you can. Don't know. People want to do it that way, but you can. All right, laws of exponents, your favorite. Oh, this one is pretty easy. Bases are the same. Again, if you want to expand it, I know expanded this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what 8 to the 9th power is. Times, and again, these are all being multiplied. Remember, exponential exponents are repeated multiplication. It's just a cheating, right? A short way of writing repeated multiplication. So 8 to the 9th times 8 to the 15th. I'm going to write it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's what this is. All these A's being multiplied. But who wants to write that? No one. So if I gave you this long thing here and I said, hey, let's use exponential power to represent that, you would say, well, that's the same thing as A. And if you counted how many A's, you would say A to the 24th power. Shortcut, keep the base, add the exponents. 9 plus 15, 24. Right? That's what the laws of exponents are, just shortcuts. You can expand it. 6 to the negative 7 times 6 to the 10th. So here, this is negative, right? So let's change that into a positive exponent. So to change that to an positive exponent, we're going to write it as a fraction. And that 6 to the negative 7 is going to come down to the denominator, and the 7 is becoming positive. And then the 6 to the 10th power was already down here. So now on the top, there's nothing to do, it's just 1. And at the bottom, we keep the base, add the exponent. Done. 5 to the negative 2nd times 5 to the negative 4th. Again, you can actually do the product rule and go, well, that's 5 to the negative 6, and then change it. 1 over 5 to the 6th power. Or if you want to change it before you multiply, you can say, well, 5 to the negative 2nd power is 1 over 5 to the 2nd power times 1 over 5 to the 4th power. Now you can keep the base and add the exponents. Either way, you get the same answer, which is this guy right here. All right, here, let's simplify. So I'll expand this. 1, 2, 3, 4, 5, 6. At the bottom we have 1, 2, 3, 4, 5, 6, 7, 8. The B's, let me change colors. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nobody's going to do this. I'm just showing you, right? So that a to the 6th, a to the 8th, we can simplify, right? These two can be simplified. A divided by a is just 1. This is also 1. This is also 1. This is also 1. This is also 1. And this is also 1. So on the top numerator, I'm left with 1. But at the bottom, I'm left with a squared. The b's, that simplifies to 1, to 1, to 1, to 1, and to 1. So I'm still left with 1 on top. And b to the 4th power at the bottom. So let's just clean that up. 1 times 1 is just 1. And then a squared times b to the 4th power is that final answer. But we're not going to do that. We're just going to look at this and say, well, there's 6 a's on the top, 8 a's on the bottom. If we simplify, right, like I just did, we know we're going to have 2 a's left at the bottom. B to the 5th power and b to the 9th. Well, if you simplify, where are you going to have b's left over? That's at the bottom. How many? 4. You can't leave the numerator empty, so we write the 1. There, much easier. This one, laws of exponents again. So if you want to change these to what they call positive, this is what I'll do. I'll change to positive exponent. So negative 2 is just negative 2. So here's my fraction. Let me clear this. Okay, here's my fraction. Negative 2 is going to stay up. V to the negative 3rd comes down, becomes positive. Z to the 4th stays upstairs. V to the negative 6 is going to come down, become positive. And then Z to the negative 3 is going to come down here. So I change my negative exponents to positive. Now I'm going to simplify. Well, negative 2 does absolutely nothing. Z to the 4th and Z to the 3rd, if you simplify, right, if you simplify 4 z's with 3 z's at the bottom, you get 1, 2, 3, 4, and at the bottom you have 1, 2, 3. This, and this all become 1, so I have 1 z left over in the numerator. V to the 3rd and times V to the 6th, we can use the product rule, right? Keep the base, add the exponent, and there we go. That's my answer. Same thing here. Let's do the coefficients. Negative 3 and negative 5 is positive 15, so I'm going to put that over here. W's, W to the 2nd power and W to the 5th power. I get W to the 7th power. They're both positive, so nothing to worry about there. The x to the negative 3 will go to the denominator, become positive. The y to the 5th will stay up. Done. X to the negative 4th power is going to the denominator, becomes positive, and z will stay up. Is that my final answer? No, because I can combine these two guys. So 15 W7 y to the 5th z over x third times x to the 4th power is just x to the 7th. There. You know what? Let me take these guys to the other page. There's no room. So, all right. So choice, you can reverse. Do the reciprocal here, right? Everybody in the numerator moves to the denominator, everybody in the denominator moves to the numerator, and change the exponent to positive. You can do that. Or you can multiply negative 3 exponent to every exponent inside the parentheses. So that negative 3, right? That negative 3, right? That negative 3, is going to multiply times this, times this, times this. The power, right? Power to a power. We're going to multiply, and there, don't forget there's a 1 there. Right? So that 3. So remember, we're raising everything inside the parentheses to the third power, which means to the third power, right? So let's do it one by one. So negative 2, no, leave that over here like this. So actually, I can remove the parentheses. So it's going to be negative 2 to the negative third power, because there's a 1 here. B, 6 times negative 3 is going to give me negative 18. C, negative 15, right? At the bottom, it's negative 3 to the negative third power again. A to the positive 15, because negative times negative is a positive. B to the positive 15, and C to the positive 15. Okay? This is gone. I'm just left with that. So let's make some travel arrangements. Negative 2 to the third power is going to go here, but with a positive exponent. And I'm going to put a little check next to it. B to the negative 18 is going to go to the denominator and becomes positive. Little check. C to the negative 15 also comes to the denominator, and the exponent becomes positive. Done. Negative 3 to the negative third power goes upstairs, and the 3 becomes, the exponent becomes positive. Check. A to the 15, B to the 15, and C to the 15 will all stay down here. So let me just, the guys who stay down here, the A to the 15, the B to the 15, and the C to the 15. Okay, we can simplify this a little further. Negative 3 times, well, these two are going to be negative. So negative divided by negative is going to be positive. So my answer is going to be positive. So 3 to the third power is 27. 2 to the third power is 8. But A, 15, B to the 33rd, and C to the 30th, right? We can, this one is just A to the 15, but these two keep the base out of the exponent. These two keep the base out of the exponent. Done. Copy this. Over here. So now, this one, and hopefully you'll write a 1 over here. Right, so it's a power to a power to a power. So 1 times the 4 times negative 5. So and then negative 2 to the 4. So imagine, let's do the 2 separately. So 2, okay, has a power of 1, who's being raised to the 4th power, and then raised to the negative 5th power. The A is currently to the negative second power, who is raised to the 4th, and then who's going to be raised to the negative 5th. So all I did was separate these two. Now, final answer is going to be all the exponents being multiplied by each other. So for the 2 is a power of 1 times 4 times negative 5. So that's going to be 2 to the negative 20th power. The A is A to the negative second times 4 times negative 5. So that's going to be positive 2 and 4 is 8. 8 times 5, positive 40. Now remember, you can't leave your answer with a negative exponent. So this guy here, so the A to the 4 stays up, but 2 to the 20, we're going to change it to a positive exponent, and therefore it travels to the denominator. Okay, we're advancing, sort of. Okay. No, I'm going to lose it. No, I'm going to lose it. Okay, same thing, right? So take this exponent and then let me put a 1 here. Take that exponent and raise everybody inside the parentheses to the negative fourth power. So it's just much easier to think distributed properly. Okay, so negative 3 to the first power, 1 times negative 4 is negative 4. So I'm going to write it like this. The k to the fifth power times negative 4 is negative 20. The m, negative 4 to the negative 4 is 16, and z to the positive 8. Not your final answer because we have some negative exponents. So m16, z to the 8th state. Negative 3 to the negative 4th power is going to come down here. And it's going to become 4 positive. And k to the negative 20 comes down here, becomes 20 positive. Almost done. M to the 16, z to the 8th, k to the 20, those are all done. But negative 3 to the 4th power is going to be a positive, and that's just 81. Right? 3 times 3 times 3 times 3. And that's your final answer. Last exponent problem. Okay, so this one is almost like the other one we just did. Now, with any of these, feel free to expand and really do it the long way. Okay. All right. So again, some of you do change this, right? You make this go here and make this go here, and then make that into positive 4. But what ends up happening is that eventually you're going to have to multiply. You still have to multiply the 4 times all the exponents inside, and you might still get some negative. And then you have to change some to the denominator and numerator. It's really up to you. All right, so let's just keep this consistent. So I'm going to put a 1 and a 1. So let's do 1 by 1. Numerator. It's negative 3 raised to the negative 4th power, right? Remember, we'll multiply negative 4 times all the exponents inside. A is going to be to the 12th power because they're both positive. Negative and negative positive. B also is going to be positive. So it's 8, and C is going to be 16. Good. The more positive, the less movement. At the bottom, negative 4 to the 1 times negative 4 is negative 4. So you know these two are going to change places. 8 to the negative 7 becomes, 8 to the negative 7 times negative 4 is 8 to the 8th power. B is going to be b to the negative 24th power, and C is going to be to the 16th. Okay. Take one step further. Well, take advantage and get rid of these two. So this is gone and this is gone, right? Because c to the 16 divided by c to the 16 is just 1. Travel arrangements. This guy, denominator, was a positive 4. Negative 4. Upstairs was a positive 4. A's, well, actually, let's simplify the A's. A to the 12 and A to the 8th, right? There's 12 A's being multiplied in the numerator and 8 A's being multiplied in the denominator. If we simplify them, we're going to have 4 A's left over in the numerator. Done. B's, well, there's a B8 here. That was already there. But this guy here, changing to a positive exponent, goes to the numerator. Stays like that. Well, we already know this is 81. On the top, we have 4 to the negative 4 times negative 4 times negative 4 times negative 4, which is 16 times 16, which is 256. Positive. A to the 4th, and then these two can be combined, and we can call it b to the 32. That's it. Now, and that takes us to the end of page 1. Okay, so next section. Give me a second. All right, this one we have to substitute, and we have to do that very carefully. And I'm going to take this to the other page as well. So let's copy. Bring this over here. Let's clear the page. So this guy here, don't need him. Make this a little bigger. All right. So first thing is substitute. Then take your negatives. So let's do the first one. So the first one we have x is negative 3. So if it's negative, I'm going to put in parentheses. And I suggest you do that. Negative 3 raised to the negative second power times y, and y is 2. 2 to the negative fourth power times z, which is negative 2, raised to the second power. So I'm doing this one right now. So let's change these. So we're going to have a fraction. This is going to come here. The exponent is going to turn positive. 2 to the negative fourth power also is going to come down here. The exponent is going to be positive. And this guy stays in the numerator. Negative 2 to the second power is just 4, so we can write it like that. Continuing, 4 over negative 3 to the second power is 9. And 2 to the fourth is 2, 4, 8, 16. There. We can simplify for a little bit more. 4 and 16, we can divide that by 4. This becomes 4, and then eventually becomes 1 over 36. That's it. All right, so my only fear here is you guys not putting parentheses if it's a negative number. The second one, right here. X to the negative fourth, so it's negative 3 to the negative fourth power. At the bottom is negative 2 times x, which is negative 3, times z, which is negative 2. All right, so the top, that's going to come to the denominator, right? So we're going to, so let me actually do this first. Let me multiply the denominator. So it's a negative times a negative times a negative. Okay, so it's going to be negative. 2 times 3 is 6. 6 times 2 is 12. So at the bottom we have negative 12. And then this I'm not going to do anything else. Now, negative 12 is already here. Negative 3 to the negative fourth power is going to come to the denominator. The exponent is going to turn positive, and that's, I'm going to put a 1 in there. We can continue. That's negative 12 times, and negative 3 times 4 is 3 times 3 times 3 times 3. It's going to be positive times 81. And the answer is going to be 1 over, you're going to have a calculator. So 12 times 81, I think. 1 over negative 972. Okay. I think the music will end before I finish the video. Anyways. Okay, again, substitute, negative 2, so negative 2 times x, which is negative 3, times z, what is z? Negative 2 to the negative third power, times z again, which is negative 2. That's what we have. Let's take care of these guys here, right? We can, there's no reason we can't. We can't multiply this guy, and this guy. So that's negative 2 times negative 3 times negative 2, which is 2, 6, and 2 is 12. That's going to give me negative 12. I'm not going to multiply that guy, this guy here. Right, because we have to. So let's change that negative exponent to positive. So we're going to write it in the numerator. There's a positive exponent. So now we can finally do negative 12, and negative 2 times negative 2 times negative 2 is 2, 4, 8, but negative. Our answer is now positive because negative divided by negative is positive, and 12 over 8 can be simplified to divide by 4, right? We're going to divide by 4, 3 over 2. That or this. All right, so nothing crazy so far. It's pretty simple. And the last one. Z to the negative, so negative 2 to the negative fourth power times negative 2 again to the negative third power over 2 times x. What's x? Negative 3 to the negative first power. So if you don't want to deal with any negative exponents, make the proper changes. So, okay, so negative 2 to the negative fourth power. I'm going to write it over here and make that 4 negative. Negative 4 positive. So, done. Same thing with this guy. Now, let me bring it to the denominator and make that negative 3 to 3. Done. So these two are taken care of. Now, this 2, here it is. But negative 3 to a negative first power, that's going to have to do a little traveling. Because the numerator and the negative 1 becomes just 1. All right. We can finally do our calculations. Negative 3 to the first power is just negative 3, so leave that upstairs. This is 2 times negative 2 to the fourth power is 2, 4, 8, 16, but positive. And negative 2 to the third power is 2 times 2 times 2, which is negative 8. So our final answer is going to be positive because the numerator is negative, the denominator is negative, so negative divided by negative is positive. There's nothing to simplify, so numerator is just 3, and at the bottom it's 2 times 16 times 8, or 16 times 16, which we found out earlier is 256. All right, so again, pretty simple so far. All right, scientific notation. Okay, so this, so we want to write this in scientific notation. Glasses. All right, so the first two, you should automatically, you should know that this is going to have a positive exponent, right? And this is also going to have a positive exponent. This is going to be a negative exponent and a negative exponent. Remember, scientific notation written as a product of two factors, where this guy here is a number that is equal or greater to 1, but less than 10. And this factor here is always a power of 10, 10 to the something power. Okay. All right, let's do the first one over here. Ugh. So remember, here's my decimal. We're going to move that decimal to the right of the first, right? First non-zero digit. So that decimal is going to travel from here all the way to here. Okay. Remember, it has to go to the right of 4 because our first factor, our first number here, has to be a number between 1 and 10, right? It could be equal to 1, but it has to be from 1 and 10. Right, x. So you can't put that decimal here because that would make that number 47 point whatever, right? And that, obviously, is not a number between 1 and 10. So our decimal is going to travel. So let me just write this. It's going to travel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Number of place values that the decimal travel becomes your exponent. And then it travels from here all the way to here, and our first factor is the number 4.785666122. And we stop after 2 because all the rest of them are zeros. And then if you multiply this times this, that's what you should get. Let's do the second one. The second one's, to count that far. So it's going to be 10 to the something power. The decimal is here. How many place values does it travel? It travels 1, right, to between 7 and 6. So my exponent is going to be 1. And the number here, my first factor, is 7.6. If you multiply 7.6 times 10 to the first power, you do get 76. The bottom two. Now the bottom two is going to be negative exponents. So it's going to be this times 10 to a negative exponent. So same thing. Move the decimal to the right of the first non-zero digit. So the first non-zero digit is 1. So 1, 2. So that decimal travels 2 spaces. So it's going to be time the negative second power. And then our first factor is going to be 1.3465435. Now, that's the same thing as 65435 divided by 100. Right, so think about what 10 to the negative second power. 10 to the negative second power is 100, right? So, and this should give you the same answer. But our answer in scientific notation is this guy. Okay? Oh my God. So many zeros. So again, this is a very tiny number, so it's going to be something times 10 to, I don't know. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to move 13 spaces. And our first digit, or not, sorry, our first factor is 5. 5 times 10 to the negative 13. That's pretty much it. Let's see what the second part is. Oh, now we're going to the other way, from scientific to standard notation. Okay. I'm gonna lose it. Did I lose it? Oh, I did. Huh. Good. Okay. All right. So now we're going to standard notation. So again, all these are just little shortcuts, right? Scientific to regular. So the first one, 10 to the negative 8. So this is it's going to be a small number, right? Less than 1, right? This is going to be a large number. Okay, so that's how you know where to move the decimal. So if it's going to be a small number, less than 1, you have to move the decimal that way. So these two, the decimal moves that way. And these two are increasing in value, so the decimal moves that way, right? Think about that. So 1.0034 and 1. We're going to move this decimal 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. What we do with the empty place values, we fill it with zeros. So 1.0001 times 10 to the negative 8th power is this number right here. Let me just clean it up. 5, 6, 7. There's my answer. Okay. Second one, 1.34. And again, we're going to move that decimal 10 places to the left. 10 place values to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. Fill the empty place values with zeros. So, cleaned up, my answer is 0 0.123456789. 2, 3, 4, 5, 6, 7, 8, 9, and then numbers 1, 3, 4. So that's what 1.34 times 10 to the negative 10 equals to in standard notation. This one, again, 2.56 times 1, 2, 3, 4, 5, 6, 7, 8. You can multiply that out if you like. Or like even on the top, you can divide it out. Right? So the shortcut is move the decimal, same number of spaces as the exponent. In this case, to the right. So 2.56, 1, 2, 3, 4, 5, 6, 7, 8. And then our new number, 1, 2, 3, 1, 2, 3, 4, 5, 6. There's our new number, 256 million. This one, 9 spaces to the right. So original number is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and a 1. Let's move that decimal 9 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So cleaned up. 1, 2, 3, 4, 5, 6, 1, 0, 0. So our number, what is that? Billion? 3 billion. So 3.000001 times 10 to the 9th power equals this in standard notation. Okay. So again. No problems. Okay. Getting close. I'm going to copy 2 at a time. Don't lose it. So let's do the top one and then the bottom one. Okay. Find the area of a rectangle that has a length of this and a width of that. Well, so if you draw it out, it helps. So they say that the length is this guy here. It's 2a to the 5th b6. And they say that the width is 12a to the 5th power b to the 2nd. So area is length times width. So all we got to do is multiply these two. So 2a to the 5th power b to the 6th times 12a to the 5th b to the 2nd. Well, coefficient was coefficient. 2 times 12 is 24. The a's, a to the 5th times a to the 5th is a to the 10th. And b to the 6th times b to the 2nd is b to b. So the area of this particular rectangle is this much units squared. Second one talks about perimeter. So draw your rectangle out. This side measures 2x squared minus x minus 2, and the other one has 4x squared minus 2x plus 5. So because it's perimeter, we're adding all the sides, right? So if the top is 2x squared minus x minus 2, so does the bottom. And this is obviously 4x squared minus 2x plus 5. So there's two ways of doing this. You can just add them and make, I'll just write it down. Because we're adding, there's no need for parentheses, right? Because the terms inside comes out exactly the same. So you can do this, what I'm doing, if you like. I add all the sides together. You can write it like this. Find it's easier. Or, well, actually, let me just do this. So x squared is this, and this. So 4a 10. So we have 12x squared. The x is negative 2x, negative 2x, negative x, negative x, that's negative 6x. And then the constants, 5, 5, 2, and 2, that's plus 6. So here's my final answer. The perimeter of that rectangle is this much. You could have done that. Now, for those of you that think that's too long, you could have, I don't know if that it's a shorter amount of work, but you can say, hey, it's 2 times this, because there's 2 of these 4x squares minus 2x plus 5, plus 2 of the other the other side. So 2 times 2x squared minus x minus 2. Now, you have less terms, right? You're not looking at too many terms, less half of the terms, but you have to do this trig problem. So you get 8x squared minus 4x plus 10 plus 4x squared minus 2x minus 4. And then combine the terms, you get 12x squared, negative 4 and negative 2 is negative 6x, and 10 minus 4 is minus 6. I think we got the same answer. So you pick whichever way you want to do. Okay? All right. Let me delete. Let's pick 2 more. How many more do we have? Oh, okay. These 2. Go. I'm gonna lose it. No, I didn't. Okay. Sorry. Now it's a triangle. Find the area of the triangle with base. So if you want to draw a triangle, draw a triangle. Doesn't matter. You're eventually going to find out there's more than one way to find the area of the triangle. So here's the base, 6m. The height of this triangle is 4aqb minus 3k. How do we find the area of the triangle? The area of the triangle is base times height divided by 2, or half base times height, however you want to write it. Well, let's substitute. So the base is 6m. The height is 4aqb minus 3k, which I'm going to write in parentheses because it's made up of 2 terms, and then divide by 2. Choice 1, do this trig property, and then divide everything by 2. Or you can, right now, simplify the 2 and the 6, make that into 3m, and then you don't have to worry about dividing by 2. So let me clean that up. So if I simplify the 6 and 2, I get 3. So I'm actually going to have 3m times 4aqb minus 3k. That might be the easier way, right? When you can simplify. So now if I multiply 3 times, so again, distributive property, 3 times 4 is 12. M times A3B is going to be just in alphabetical order, A cubed BM. 3 times negative 3 is negative 9, and then M times K alphabetically is just Km. So here's the area of your triangle, units squared. The rectangle has a perimeter of, did we just not do this? Oh, okay. So here's a rectangle, it's a different type of question, sorry. If you add all the sides in the rectangle, it says that the perimeter is 30x plus 18. You're given that the length, this guy here, measures 5x plus 1. So if this guy measures 5x plus 1, you know that this guy on top measures 5x plus 1. So the question is, how much does that side measure? Right? That's what they're asking. So what we can do is go 30x plus 18. And from that, I'm going to subtract this guy over here and this guy. So whatever I have left over is going to be these two sides, right? The two widths. And because I'm only asked for one of them, I just got to divide that by 2. So let's do that. So 30x plus 18. So let's subtract 5x plus 1, which you have to put in parentheses. And now I subtract the other one, 5x plus 1. You could have added these two and just made it 10x plus 2. Same thing. Your call. Okay. So let's do that. 30x plus 18. Let's remove the parentheses. So remember, this subtraction sign is going to make everybody inside come out opposite. So minus 5x, minus 1, and likewise for the other one. So minus 5x, minus 1. Combine like terms, we have x, x, and x. 30x minus 5x is just 20x. 18 minus 1 is just positive 16. So this is the length of two of the width together, right? This side and this side together. So because they're asking us just for length of the width, we got to divide that by 2. So take what you found, right? 20x plus 16 and divide it by 2. So be very careful. We got to divide this guy by 2 and this guy by 2. And if you do that, you get 10x plus 8. That makes sense, right? Because 10x plus 8 plus another 10x plus 8, it does give you 20x plus 16. If you have the time and you want to confirm, you can now, right, so note that what these two are. If you have the time, you can add, go for the whole perimeter, add all 4 sides. Does it really give you 30x plus 18? And if it does, you have done it correctly. Okay. And I think we have one more question. Copy. And remove it. Okay. Okay, so read the question, and I just got it. All right, so your bonus words are going to be 2 countries that start with the letter Z. Okay, not that statement, but I actually want the name of the countries. Okay, so that's going to be your bonus word. You're going to have to do a little research, figure it out, and then write the name of those 2 countries on the test. Okay, a rectangle has some. Let me draw the rectangle. This rectangle has a length of 4x plus 2y minus 1. The width, this guy here, is 3 less than 4 times the length. So let's translate that to math. Okay. 3 is 3. What does less than? What operation does that stand for? Less than, you should know, is subtraction. 3 less than 4 times who? The length. Do we know the length? We do. It's 4x plus 2y minus 1. Now, there's one thing that we have to do. The word less than, I call it, or I used to call it in the 6th grade, a turnaround word, right? So less than actually means that these two terms have to change position. So it's actually 4 times 4x plus 2y minus 1 minus 3. All right, so those two. Anytime you see the word less than, when you're translating it, right, you got to make sure you change the order of the term. So the second term becomes the first, and the first term becomes, they switch positions. So the width now is expressed as this. Right? Write an expression to represent the perimeter. Well, so now that we have that, we actually can take this guy here and simplify it a little bit more, right? So let's do the distributive property. 4 and 4x is 16x. 4 and 2 is 8y. And then 4 times negative 1 is negative 4. Minus 3, 16x plus 8y minus 7. So let's erase this, right? And we can replace it with 16x plus 8y minus 7. And then we can write 16x plus 8y minus 7 because the rectangle. And this one is 4x plus 2y minus 1. Okay? Now they want the perimeter. Well, now comes the easy part. All we just do is combine my terms. So again, the other previous problem, I wrote everything down. So all 4 expressions in Atom. So this one, let's do it using the root bar. So it's 2 times 4x plus 2y minus 1, right? So it's twice because there's 2 of them, plus 2 times 16x plus 8y minus 7. That becomes 8x plus 4y minus 2, and this becomes plus 32x plus 16y minus 14. We can finally combine like terms. 8x and 32x is 40x. 4y and 16y is plus 20y. And negative 2 and negative 14 is negative 16. So there's my perimeter. But we know that x equals 8 and y equals 5. So we can actually get a numerical value. So 40 times 8, because x equals 8, plus 20 times 5, because y is 5, 16. 40 times 8 is 320. 20 times 5 is 100, minus 16. These two give me 420, minus 16, and my final answer. So the perimeter of that rectangle is 404 units. Okay. That's it. Okay.